PDCA is an iterative four-step management method used in business for the control and continuous improvement of processes and products. It is also known as the Deming circle wheel, Shewhart cycle, control circle cycle, or plan do study act. Another version of this PDCA cycle is OPDCA. The added O stands for observation, or as some versions say, grasp the current condition. This emphasis on observation and current condition has currency with lean manufacturing Toyota production system literature. Meaning: the steps in each successive PDCA cycle are: plan, establish the objectives and processes necessary to deliver results in accordance with the expected output. By establishing output expectations, the completeness and accuracy of the spec is also a part of the targeted improvement. When possible, start on a small scale to test possible effects. Do, implement the plan, execute the process, make the product. Collect data for charting and analysis in the following check and ACT steps. Check, study the actual results and compare against the expected results to ascertain any differences. Look for deviation in implementation from the plan and also look for the appropriateness and completeness of the plan to enable the execution, that is, do. Charting data can make this much easier to see trends over several PDCA cycles and in order to convert the collected data into information. Information is what you need for the next step. ACT. ACT, request corrective actions on significant differences between actual and planned results. Analyze the differences to determine their root causes. Determine where to apply changes that will include improvement of the process or product. When a pass through these four steps does not result in the need to improve, the scope to which PDCA is applied may be refined to plan and improve with more detail in the next iteration of the cycle, or attention needs to be placed in a different stage of the process. Note: some modern trainers now also refer to the A as adjust. This helps trainees to understand that the fourth step is more about correcting the difference between the current state and the planned state instead of thinking that the A is all about action and implementation stage. About PDCA was made popular by Dr. W. Edwards Deming, who is considered by many to be the father of modern quality control. However, he always referred to it as the Shewhart cycle. Later in Deming's career, he modified PDCA to plan, do, study, act, because he felt that check emphasized inspection over analysis. The concept of PDCA is based on the scientific method, as developed from the work of Francis Bacon. The scientific method can be written as hypothesis experiment evaluation, or plan, do and check. Shewhart described manufacture under control under statistical control as a three-step process of specification, production, and inspection. He also specifically related this to the scientific method of hypothesis, experiment, and evaluation. Shewhart says that the statistician must help to change the demand for goods by showing how to close up the tolerance range and to improve the quality of goods. Clearly, Shewhart intended the analyst to take action based on the conclusions of the evaluation. According to Deming, during his lectures in Japan in the early 1950s, the Japanese participants shortened the steps to the now traditional plan, do, check, act. Deming preferred plan, do, study, act because study has connotations in English closer to Shewhart's intent than check. A fundamental principle of the scientific method and PDCA is iteration once a hypothesis is confirmed, executing the cycle again will extend the knowledge further. Repeating the PDCA cycle can bring us closer to the goal, usually a perfect operation and output. Another fundamental function of PDCA is the hygienic separation of each phase, for if not properly separated, measurements of effects due to various simultaneous actions risk becoming confounded. PDCA is also known as a system for developing critical thinking. At Toyota, this is also known as building people before building cars. Toyota and other lean companies propose that an engaged, problem-solving workforce using PDCA is better able to innovate and stay ahead of the competition through rigorous problem-solving and the subsequent innovations. This also creates a culture of problem solvers using PDCA and creating a culture of critical thinkers. In Six Sigma programs, the PDCA cycle is called define, measure, analyze, improve, control. The iterative nature of the cycle must be explicitly added to the DMAIC procedure. Deming continually emphasized iterating towards an improved system, hence PDCA should be repeatedly implemented in spirals of increasing knowledge of the system that converge on the ultimate goal, each cycle closer than the previous. One can envision an open coil spring, with each loop being one cycle of the scientific method, PDCA, and each complete cycle indicating an increase in our knowledge of the system under study. This approach is based on the belief that our knowledge and skills are limited, but improving. Especially at the start of a project, key information may not be known. The PDCA scientific method provides feedback to justify our guesses and increase our knowledge. Rather than enter analysis paralysis to get it perfect the first time, it is better to be approximately right than exactly wrong. With the improved knowledge, we may choose to refine or alter the goal. Certainly, the PDCA approach can bring us closer to whatever goal we choose. Rate of change, that is, rate of improvement, is a key competitive factor in today's world. PDCA allows for major jumps in performance, as well as Kaizen. In the United States, a PDCA approach is usually associated with a sizable project involving numerous people's time, and thus managers want to see large breakthrough improvements to justify the effort expended. However, the scientific method and PDCA apply to all sorts of projects and improvement activities. See also, AIDA process, business process improvement, COBIT, DMAIC, lesson study, OODA loop, performance management, quality storyboard, Robert S. Kaplan, theory of constraints, total security management, Six Sigma, lean, references. Further reading, Shewhart, Walter Andrew. Economic Control of Quality of Manufactured Products / 50th Anniversary Commemorative Issue. American Society for Quality. ISBN A0-87389-076-0. The Improvement Guide, A Practical Approach to Enhancing Organizational Performance, 2nd edition by Gerald J. Langley, Ronald Mon, Kevin M. Nolan, Thomas W. Nolan, Clifford L. Norman, Lloyd P. Provost. Published by Jossey Base. ISBN 978-0-470-19241-2. Shewhart, Walter Andrew. Statistical Method from the Viewpoint of Quality Control. New York, Dover. ISBN A0-486-65232-7. Deming, W. Edwards. Out of the Crisis. MIT Center for Advanced Engineering Study. ISBN A0-911379-01-0. External links, PDCA Guidance.